Okay, so we get to chapter 10, and now we're doing something completely different. It's a mathematical idea called sequences, and it's a way of doing repeat multiplication or addition in a concise form. It comes up a lot in higher math. So this is an introductory topic. It's getting you used to some notation, also just the basic idea. So there's two sequences in this chapter, arithmetic and geometric. And again, I'm modeling my examples along the lines of the quiz. So an arithmetic sequence is always in the form a to the n is equal to a sub 0 plus dn. So this is basically a linear equation, but we can do more with it. We can add successive terms. All right. So they tell us that a to the 1 equals 3 and d equals 4. They actually give us a lot of information here. And we're asked to find a to the n, which we call the general form, and then use it to evaluate a 29. All right, so what we do is we just start with a to the 1. We know that's equal to 3. So a to the 1 is going to be equal to a sub 0, so the initial value of this sequence, plus dn. And we can fill in some of these numbers. They tell us a to the 1 is equal to 3. We don't know what a sub 0 is, but they do tell us that d is equal to 4. And if we're looking at a to the 1, then that means that n is equal to 1. Okay, so from this, we can easily solve for a0. Subtract 4, and we get a sub 0 equals negative 1. All right, so here's my general form. A to the n equals a sub 0, which we just figured out was negative 1, plus d, which they gave us. There's my general form. And to evaluate a 29, I'm going to use the negative 1 plus 4 times 29. When I do the math, I get, well, I haven't done the math yet, so give me a second. Okay, so 4 times 29 is 116. We'll get 150. Okay, next problem. In an arithmetic sequence, they're telling us that a to the 6 is equal to 7, a 16 equals 27. Find a sub 1 and the common difference, and also let's figure out what a 32 is. Okay, again, our arithmetic sequence looks like this. And we're going to do some substitution for a to the 6 and a 16. So a to the 6 is equal to a sub 0 plus dn. And I'm going to substitute a to the 6. I'm going to substitute a 7 in. And also for a sub 6, that means n is equal to 6. All right, so simplifying that, I get 7 equals a sub 0 plus 6d. I'm going to do the same thing with a 16. Okay, so what I have after doing this, I have two equations with two variables. And if I multiply one of these equations by negative 1, it'll cancel out the a sub 0s. I'm just going to solve this like a system of equation using elimination. And it looks like it's going to be easiest to multiply this by negative 1. So I get negative 7 equals negative a sub 0. So my a sub 0s will cancel. minus 16. So when I combine those, I get 20 equals 10d. And then solving for d, looks like d is equal to 2. Okay, I can take that and substitute it back in to the previous equation. I can substitute into the 27. This just has smaller numbers. So I'm going to put in the 2 I just figured out for d, and now I'm going to solve for a. So 7 equals a sub 0 plus 12. So it looks like a sub 0 is equal to negative 5. Now I can write my general form. A to the n equals negative 5 plus 2 times n. All right, so find a sub 1. All right, so d is equal to 2. They ask us for that. And a sub 1, I'm just going to put in a 1 for n. Negative 5 plus 2 is negative 3. And I'm going to do the same thing with A32. All right, 2 times 32 gives 64 minus 5 gives 59. Done with that problem, and I'm going to stop this video.